Hi, welcome to my channel for some Guardium collectors administration considerations based on my experience as professional services with IBM and my recent practical experience at AIM, where I manage by myself about 50 collectors without this taking more than 10 to 20% of my time. Today, we are going to clarify something many feel strange at first, which is those question marks we see in the SQL recorded in Guardium, but do not exist in the traffic itself, right? So the question is, what is it and where does it come from? So in Guardium, we see those kind of SQL statements recorded, right? So for example, here this one, select star from CCN with credit card number where credit card ID equal and question mark. Now this doesn't exist in actual SQL traffic. So, and this is also different from two other forms of the SQL we see in Guardium, which is, for example, this one, select star from CCN, where CCID is equal and a set of stars, or select star from CCN from where CCID is equal and here a number. Then those are the three forms we can see in Guardium, okay? But only the last one is a actual SQL statement. It's really what was executed. Then if we look at the next one here, this is a masked SQL statement, so in which the values are replaced by a number of stars, right? So it is what was executed, but in this case the collector has masked the values, right? Has masked the values, and it's a collector which is the sniffer, the parser. And the last one is a construct, what Guardium calls a construct, and it's what was executed, but the collector has rewritten it as if the SQL statement used only bind variable for the values. Okay, so let's have a look at what the bind variables are. Okay, so bind variables are standard stuff in SQL, right? It's something that exists, and here's an example with Oracle, right? So the way it works, right? So for example, if you at the prompt, SQL prompt, you set up a variable. In this case, it's phone number, right? And then you set it up that way. So you set it up, and meaning that you assign a value to the variable, right? And so now you execute the SQL. But here you don't put in the where clause, you don't put the actual value, you just put the name of the variable. Okay? Guardium does the same thing as this, right? Except that instead of putting the bind variable, it puts the question mark. But this is basically the same process, right? And this is called construct in Guardium, right? So now let's look at how the collector does that. So here we're going to look at what the SQL looks like in the traffic, what it looks like processed by the parser, which is the collector, and what it looks like once it's written in MySQL, Guardium MySQL, in the instance entity. Okay, so in the traffic, let's say you've got this SQL statement executed many times, and here the value changes, right? So you've got 7 SQL statements with 7 different values. Okay, so those SQL statements are all different from each other, except that now, if you do like the parser and you replace the values by question mark, right? Now you've got, and this is what the parser does, now you've got those 7 SQL statements, but they look exactly the same. Okay, looking exactly the same, instead of storing all of them, which takes room, you can just store one of them, right, and manage a counter, right? So you can now imagine this is just 7, but imagine you've got 10,000, right? 10,000 here. So in MySQL, in the instance entity, we're going to have this SQL statement, and the counter will be 10,000. Then we go from 10,000 records just to 1, right? And the counter in Guardium is called total access. When you see total access in Guardium, is the counter of number of time the SQL seen as a construct has been executed. Well, there are some things you can see. So we lose the values right here, but you know, this is good actually, because if you don't, in this case, you're going to store credit card number. If you store credit card number, your Guardium appliance become part of the PCI scope, and you don't want that, right? So this is good. And do you really need the name, the number, the credit card number itself? Probably not, unless your auditors want that. But in this case, it's going to be part of security requirements, right? It's not going to be your decision, and it's going to be the auditor decision to put Guardium within the scope of PCI, with all the consequences it has. So in general, this is good, right? And we can save a lot of room. At the same time, not only we lose the values here, but we also lose the timestamp when it was exactly executed, which is fine, because in this case Guardium creates periods, right, of 1 hour, and the counter is managed per hour. So I'm going to see that a little bit in more details. But now you know what those question marks are. It's just the replacement of the value in order to store the SQL as a construct, which is the SQL rewritten as if it was only using a bind variable. And you have a reduction of the room taken by the traffic recorded, which can be substantial. So now let's see exactly how all this is stored in the database, in the MySQL database on the collector. And this, to me, it's a great design of the Guardium database, right? So the design of the table, the join, it's really great. So, and this is what we're going to see now. So to really appreciate and understand the design of this database and why it's a great design, there are a few prerequisites on things to understand. Well, first, mostly because log SQL traffic is not some kind of standard or regular or usual log, okay? Then, database activity monitoring and the log the corresponding log is about to know who connected to the database, when they connected, and what they did while connected. So who connected, it's the database logging string. So, when they connected, it's what is called the session, or database session, and what they did while connected is the SQL. Okay, it's a who, when, what. And this is what you want to know when you do database activity monitoring. And at any point of time, you must be able to answer auditors on this question, right? So you see that there are three parts, and in the database, it's stored as three different components, and they have relationship between them. There is a relationship between the who and the when, between the when and the what. Okay, and those relationships are described but hidden to the user, but are described and implemented according to what is called an entity relationship diagram. Okay, so I think it's those things in Guardium for you from outside. It takes the form of what Guardium calls domain and entities. So I'm going to explain what domain is, but entities is directly coming from this entity relationship diagram, or ERD. Okay, and so you got an idea of the entity. Now we're going to look at the relationships between them. So here we're going to look at the who, when, what from a kind of high-level conceptual standpoint. Okay, so you've got the who, when, what, and you've got a relationship between each of them. Okay, and this relationship is called cardinality. Okay, so it's in case of who and when, it's a 1 to n relationship, meaning that one who connected several times. So one who to n when. And you've got the same thing. When someone is connected, they can, for one session, right? The what, which is the SQLs, they execute several of them. So you've got for one session, you've got several SQLs. And this is the basis of the database, the Guardium database, and basically any database recording database traffic. So here is an example. Okay, so still on the left the concept, but an example will be that. So who connect? It's me, for example. I connected 3 times, right? So here those are the time I connected, and here you've got what I did while connected. So here on that day I executed only one SQL, right? On that day here I executed only one SQL, but on that day I executed 3 different SQLs, right? So this is how it works, and the database Guardium is based on that, plus the construct. But now if we want to get into the actual implementation, design and implementation of the database, right? So we're gonna it's better to present it not vertically but horizontally this time, because it takes more room. So, but here you got the same thing, right? Here it's the who connected, when they connected, right? And here this whole piece here, it's what they did while connected. Okay. When we use the construct, right? So a session, a guy connects several times. So we're going to take now one session, right? That person did several SQL, and we're going to store the SQL that way. We're going to store the SQL in 2 different tables or entities. Okay. So first, since we've seen the SQL as a construct, you remember that it has to be stored only once, right? And this is what we do here. It's a SQL itself, and we assign, Guardium assigns a SQL ID, or construct ID actually. It's a CID, construct ID. And this one, we're going to say it's a construct ID 1. Okay? And the counter is going to be managed that way. So we, in what they call instance, they create a record for each hour, right? And it goes from the top of the hour to the top of the hour. It's 1 hour, okay? And it says that for this construct ID, the total access was 20,000, for example. Okay? So instead of repeating in each of these record here instance the SQL itself, we just repeat the construct ID, which is a small number, right? So it doesn't take much room. So an instance is built that way instead of having only one big one counter for all access during that session on that construct on that SQL seen as a construct. They split it per hour, but it's the same, conceptually it's the same, right? So now, why is it a great design? Because the great design conceptually is that, okay? The great design, it's this instance, right? This instance entity or table, right, has actually received two 1-to-n relationship, but in different direction. And this is what is great, right? So here between session and instance you've got 1-to-n, but between SQL you've got 1-to-n as well, but in other direction. So basically here, what makes this design really great is that and that on the same instance. And I think there are patterns on that which make sense. Okay, so now let's talk about full SQL in this design. Okay, in this design, full SQL is actually one record for each actual SQL. Okay, so now if we look at that, we are going to record this one or masked. Okay, so next to, in addition to the instance and where we lose the values and the exact timestamp, exact time the SQL was executed, now actually what we do in full SQL is really for each SQL to record it. And since it can be that way, right, it has to be each individual SQL, and here the construct ID cannot replace the SQL itself, right? So when you do full SQL, it's what you do. You record each individual SQL with the SQL itself. So if the SQL is massive and it's been executed 10,000 times, you're gonna record 10,000 times this massive SQL. This is why full SQL is in general the massive and very large table and entity, right? This is the reason, but we know why, okay? And it's why full SQL, it's not a good idea necessarily to record everything as a full SQL, right? Maybe you can focus on specific stuff, right? So, but this depends upon your security requirements and nothing else. So if we keep going on the design of the MySQL database, so the next step is to see that the SQL, the construct, is actually parsed and broken down between two components, the command and the object. And this is from SQL. So now you've got really not only you know what was done, but you've got a better idea, structure idea of the SQL itself, because SQL is almost unstructured data, and by doing that you convert it into structured data. So you can take a select statement, and just by looking at that you can say those are the command executed in this SQL, and those are the object touch, right? So once we've got that, we can discuss and present what something very important in Guardium, which is the difference between static and dynamic data. Basically, static data are entities in which there is no timestamp. Okay, and the entities where there is no timestamp are the SQL statement as a construct and the different components. And you can look in you won't see any even if you go directly to the database, you won't see any timestamp. There is none. Client server is considered as static as well, whereas there is a timestamp, but basically the timestamp doesn't really count. It doesn't count. So the static data are really those ones. The rest is dynamic. The rest, there is a timestamp, right? So we can call them also historical, whereas the static one are kind of permanent one. Okay. So these are some major consequences when it comes to upgrade and purge. So let's see the purge first. The purge applies only to the dynamic data. When you purge only the gray pieces. It doesn't purge anything here. And what happened, right, as opposed to what they assume when they design Guardium, right? Say what happened, it's actually those permanent stuff really grew a lot, much more than anticipated, right? And the problem it's for a long time Guardium didn't have a way to purge those static ones, right? So as a result, now if you do a purge, right, and since the purge reduces only the dynamic data, if your static data part is pretty large, you are not going to reduce the size of the database much, because this is never going to be touched, right? So it's why sometimes you can purge and you still have a lot of data. Yeah, because those are static data. Okay, but this also has a consequence on the upgrades. Okay, so as you know, the larger the data, the longer the upgrade, right? And it's why Guardium asks you to purge as much as you can. The problem is, for a long time, since you could only purge the dynamic data, you couldn't reduce the static data, right? And the amount of data on your collector was, or aggregator for that matter, was still pretty large. Okay? And therefore, even after purging a lot, the time taken by the upgrade was still pretty large. Okay? And so Guardium eventually implemented a way to purge the static data, and this relies on a field in those static entities, right? And this field is the last used, right? When it was last used. But this field is populated only if you activate that feature, right? This is not something that get populated by default. Anyway, it was that way some time ago. However, in terms of upgrade, if you have Sonargy or Guardium Insight or Context22 add-on for Guardium, okay, basically you don't need to upgrade a collector. And since you don't have, you don't use aggregators, you don't need to upgrade aggregators. And why you don't need to upgrade collectors when you've got those products, especially if you have a VM, and you once those products you send the data from the collector every hour. Then past 1 hour, if you stop the sniffer, you wait 2 hours, and all the data, even if they are in the database, they are directly sent to outside. So you don't need the data anymore. So you can just rebuild a collector. So the impact on upgrade is less, because actually the best option is just to rebuild a collector. You don't need really to upgrade one. Okay, so last thing, it's Guardium uses the terms of domains and entities, whereas it doesn't really exist into actual databases. The term entities exist and is used when you design at the conceptual level the database within the entity relationship design, right? But when it comes to the database itself, you know only tables and joins. Okay, so what's the difference between entities in Guardium and tables, basically? And what are domains for Guardium? Because this is not also something that you can, it's not a term used in databases. Okay. So first, when it comes to the entities, there are what is called database views. Okay, the views in database is actually a standard concept or tool, right? They are read-only access to tables, right? And those read-only access to tables, to several tables, include the joins, right? So with views, which Guardium basically call entities, right? So with views, there is no need to define or work out the joins because they are built in the definition of the view, right? And Guardium takes full advantage of this. So it's why you can pick and choose fields in the report, without having to declare or to worry about the join between the table in which those fields are. So this is for the entities. So what are domains in Guardium? So Guardium could have present only one domain between the entire database. Actually, what Guardium does, and it's pretty good, it's to give you a different view, specialized view of the database, right? Some domains are subpart of the database, right, and contains a set of views which are read-only access to tables with the joins built in, and you don't have to worry about that. Then we're gonna just, before we conclude, present the main of those domains. Then what are those main Guardium domains? Okay, actually there are two types of domains. So you've got the DAM data domains, right? Really the domains where you're gonna find the data of the database activity monitoring, basically where you're gonna find the traffic. And you've got domains where you're gonna find everything else, right? So everything else being performance information, configuration, all this kind of stuff that are needed to manage the database, the collector, and this list is very long. Okay, and sometimes it's a little bit confusing because you are wondering what all those domains are, and actually it's non-DAM data domains, right? So you go through the list and it makes more sense, right? When you read the name, thinking that it's not about the traffic. So when it comes about the traffic, right, there are three main domains. Okay, there is the access domain, which is basically the regular and successful traffic. This is where you're gonna find the who, when, what. Okay, so this is and you just need to work with this domain. They created some subdomain of this one, some more specialized just on for example sessions, right? Sound and this kind of stuff, but you can figure it out by looking at the name and the content, right? But access domain, it's where you can see all the regular and successful traffic, so who, when, what. So you've got the exception domain, which is the unsuccessful traffic, so in which you're going to find two things: the failed logins and the SQL error. And the third domain is the policy violation, which is not used much but it's a successful and unsuccessful traffic flagged by your policy as violation, right? Then these and they may be, I'm not sure, but don't remember exactly, but they may be subdomains of those domains. But this is easy to figure out once you understand that. You look at the content of those subdomains and you realize that there are subdomains, and you can figure out what domains they are the subdomain of. Okay? So this takes us to the end of this presentation, right? If you've got questions, anything, you can contact us here with these different things. And if you want the deck of this presentation, please email us at info@context22.com, and we will be glad to send it to you. Have a good day.